To understand about the implicit differentiation, for example, let's say you have y equal x squared. Then if you want to find out the derivative of y with respect to x, it's easy. You can just say, okay, derivative of y with respect to x is, just use the power rule, which is 2x. So here is the relation between y and x, and there we can see direct relation. Okay, so finding the rate of change of y with respect to x is easy. But for example, let's say we have different kind of equation like x squared plus y squared equal 1. Okay, so we know that this equation represents a relation between x and y, but it's not direct relation like where you can find y as a function of x like this, y as a function of x. Here we don't have y equal something. So in this kind of scenario situation, if we want to find out derivative of y with respect to x, then that's called implicit differentiation. Where you have an equation between variables, but it's not easy to express y as a function of x like this. Then still you need to find out the rate of change of y with respect to x. Then we need to do a derivative. That derivative is called implicit differentiation. So how do we do that? So this is the problem. For example, x squared plus y squared equal 1, and we want to find out the rate of change of y with respect to x here. Then to do that, to do the implicit differentiation, first of all, differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. So if we try to find out the derivative both sides with respect to x, that's our first step. The derivative of x squared with respect to x, which is 2x, and derivative of y squared with respect to x, and on the right side the derivative of 1 with respect to x is 0. Remember, when we do the implicit differentiation, this is what we need to understand. The derivative of x to the power n with respect to x is n times x to the power n minus 1. That's called power rule. But if you are looking for the derivative of y to the power n, n could be any integer. It's not the same one, okay? It might be different one. And here we are trying to find out with respect to x, the derivative of this can be found by using implicit differentiation, okay? Meaning we can use the chain rule, and then we can find out the derivative of this. So the derivative of this can be found by using the chain rule. So first of all, find the derivative with respect to y, and then just multiply that by dy over dx. This dy and this dy, they are just cancel out. So eventually that is n times y to the power n minus 1 times dy over dx. So whenever we need to find y to the power something, find the derivative of y to the power something, this is the formula we are going to use. So here in this problem, step 2, the derivative of x squared is 2x. The derivative of y squared is, by using this formula, it would be 2 times y times dy over dx. So now, because we are looking for dy over dx, so we bring everything on the right side. So meaning just subtract 2x first, and that will be 2y times dy over dx equal negative 2x, and then divide both sides by 2y. So if you do that, so the derivative of y with respect to x is negative x over y. Okay, that's the answer. The derivative of y with respect to x is negative x over y. So this derivative is called implicit differentiation. Let's do some more examples here. Let's say we have an equation between x and y. This is the equation, and using this equation we want to find out the rate of change of y with respect to x. So we're going to follow these steps, step 1 and 2. We're going to find out the derivative both side with respect to x. So differentiate both side, differentiate both sides with respect to x. So while differentiating, you have to differentiate every single terms. So you have to differentiate x cubed, which is 3x squared, Now when you try to find the derivative of the second term, which is negative 27xy, if you try to find out the derivative of this, because there is a x times y, you have to use the product rule. So you can bring that negative 727 outside and use the product rule for x times y, the derivative of x times y. So if you use the product rule, the first time find the derivative of x, which is 1, so the leftover is y, plus second time just leave the x and find the derivative of y with respect to x, which is dy over dx. So that's the derivative of the second term. If you distribute this negative 27, it will be negative 27x times dy over dx. So eventually that is negative 27y minus negative 27x dy over dx, plus find the derivative of y cube. If you remember this formula here, the derivative of y cube with respect to x is 3 times y squared times dy over dx. So that's a 3 times y squared over times dy over dx. So these are the derivative for the first, second, and third term on the left side. The derivative on the right side is 0 because derivative of 1 with respect to x is 0. Now that's the first step. Differentiate both sides of the equation with respect to x. Now the second step is collect the terms with the dy over dx on the one side. So as you can see that this term has a dy over dx, this term has a dy over dx. So we just keep them on the left side and everything else will go to the right side. So we have to bring this 3x squared to the right side. We have to bring this 27y to the right side. And we can do that if we just subtract. So if we just subtract, let's say 3x squared and add 27y, subtract 3x squared and add 27y. If we do that, that will give us this thing. Now just in between these two terms, just factor out dy over dx and write down the leftover thing here. So I'm going to factor out dy over dx. The leftover thing would be negative 27x plus 3y squared, and on the right side it's a negative 3x squared plus 27y. Okay, so now to find the dy over dx, just divide both sides by this thing. uh, so let's do that. So here, okay, so we have to find dy over dx. We have negative 27x plus 3y squared on the left side. So let's do that here. Let's divide both sides by this. So I'm just going to divide both sides by this negative 27x plus 3y squared negative 27x plus 3y squared. So the dy over dx is dy over dx is dy over dx is, just copy that, copy this one, negative 3x squared plus 27y and negative 3x squared plus 27y over negative 27x plus 3y squared, negative 27x plus 3y squared. If you want to simplify this more, you can factor out negative 3 on the top. That will give you x squared minus 9y, and negative 3 on the bottom. That will give us 9x minus 3y. So we can cancel this 3 and negative 3. So eventually the derivative is x squared minus 9y over 9x minus 3y. So that's the answer. Okay. Okay, so let's go to the next page. Find out the derivative. Before you do the derivative, first of all, we have to know this. The derivative of EU where u is function of x, derivative of this kind of function with respect to x is eu times derivative of u with respect to x. Okay, and another thing is, if you have sine v where v is also function of x, then derivative of sine v with respect to x is cosine v times dv over dx. Okay, so we're going to use that fact here. So because this is a relation between x and y, so we need to do the implicit differentiation. So differentiate both sides, differentiate with respect to x. So on the left side, by using this formula where u is 7x, the derivative is e to the power 7x times derivative of 7x with respect to x equal, the derivative of sine x is cosine x plus 2y times, look at here, the derivative of sine v is cosine v times dv over dx. So in this case, v is x plus 2y, x plus 2y. So on the left side, e to the power 7x, the derivative of 7x is just 7. On the right side, it's a cosine x plus 2y, and find the derivative of x, which is 1. Derivative of 2y is 2 times dy over dx. Our ultimate goal is to find the dy over dx, and for that we can bring this thing on the left side and 1 on the left side, and that will give us dy over dx. So if I simplify this, 7 e to the power 7x minus cosine x plus 2y minus 1 equal 2 times dy over dx. So since our goal is to find dy over dx only, just divide both sides by 2. So that is our dy over dx. That's the final answer. 7 times e to the power 7x minus cosine x plus 2y minus 1 over 2. Okay, let's go to next problem. The next problem is find the tangent line. Make sure that if you have a curve and if you want to find equation of tangent line at any point, in this case it's 1 comma 7, you need to find the slope of that curve at that point. Slope means derivative, so you need to find out the dy over dx at this point. So here, as you can see that the curve is x squared times y squared equals 49, so we need to use the implicit differentiation for finding the slope. So let differentiate this equation, differentiate with respect to x. On the left side, you can see that there is x squared times y squared, so you have to use the product rule. And if you use the product rule, you have to find out the derivative of x squared for the first time by leaving the y squared, and then you have to leave x squared and then find the derivative of y squared. And on the right side, the derivative of 49 is 0, so the derivative of x squared is 2x times y squared, and this is x squared times the derivative of y squared is 2 times y times dy over dx. So eventually dy over dx is, bring this term to the right side, so just subtract 2x y squared and then divide this by this one, 2x squared y. So dy over dx would be negative 2xy squared coming from here, and then divide by this, which is 2x squared y. If you divide by this term, you can cancel 2 and x and y. So eventually the derivative is negative negative y over x. So that's the slope. That's the rate of change of this curve, but we need to find out the slope at 0.17. So we need to find this dy over dx at 17. So I'm going to do that here. Slope of this tangent line is dy over dx when x is 1 and then y is 7. So just plug here this value, negative 7 over 1. So the slope of the tangent line at this point is negative 7. So what is the equation of tangent line? Equation of the tangent line is y minus y1 equals slope x minus x1. Equation of any line with a given slope m and passing through a point x1, y1 is this one. So we just have to plug the value of slope, which is -7, x1, which is 1, and y1, which is 7. Okay. So let me just add one more line here. M is -7, x1, y1 is 1 comma 7. That's the value, right? X1, y1 is 1 comma 7. The slope is -7. The equation is y minus y1, which is 7. Slope is -7 times x minus x1, which is 1. So if you just distribute this -7 here, it will be -7x positive 7. So if you add just 7 here, eventually y equal -7x plus 14. So this is the equation of tangent line at this point 1, 7. We also have to find the normal line. The relation between the tangent line and the normal line is they are perpendicular of each other. So meaning is if m is the slope of this tangent line, then -1 over m would be the slope of this normal line. So we already know that the slope of the tangent line is -1 over 7. So slope of the normal line, slope of the normal is reciprocal, negative of reciprocal of this. So negative of 1 over m, which is negative of 1 over -7, which is 1 over 7. Now the equation of normal is, the very same equation, but we just have to replace this slope by 1 over 7. So equation is very same point, which is y minus 7 equal, the slope is 1 over 7 instead of -7, x minus 1. So you just have to simplify this. You just have to bring this 7 to the right side and simplify the, for y, which is x over 7 -1 over 7 plus 7. That gives you positive 48 over 7. So this is the equation of the norm. Okay.